In the HVAC industry, one of the main services we provide is comfort. We do so by installing and maintaining the equipment that heats and cools customers' living and working environments. In heating, we achieve this goal by adding heat to the conditioned space when it is cold. The way we accomplish it today is through controlled heat transfer using various heating appliances. Fundamentally, all the appliances are the same. They are designed to produce heat and in one way or another deliver it to a conditioned space. All appliances have a heat producer, a flame sensor, a heat exchanger, a method of protecting the equipment from damage due to high temperature and/or pressure, a method of disposing of the combustion gases in a safe manner, and a method of distributing the heat produced. In heating, the main appliances we use to add heat to a conditioned space are warm air furnaces, steam boilers, and forced hot water boilers. A warm air furnace uses air to carry the heat to the conditioned space. The forced hot water boiler and steam boiler use water and steam to carry the heat to the conditioned space. The appliances are designed to work with various fuel types. The main fuels used today are oil, natural gas, and propane. An oil-fired appliance is distinguishable by the burner that is used to deliver the flame to heat whichever medium is being used to carry the heat. There are different types and designs of oil burners, but they all work on the same principle. A gas-fired appliance uses a manifold to heat whichever medium is being used to carry the heat. Again, there are different designs and types of gas manifolds. We are not going to cover how the gas manifold or burner functions. For now, it is important that you are able to distinguish the difference between an oil-fired appliance and a gas-fired appliance. If you look at the pictures of the oil-fired appliance on the lower left and the gas-fired appliance in the lower center, you should notice that the gas manifold and burner are mounted inside the cabinet behind an access panel. On some furnaces, the burner could be mounted externally. If the burner is mounted internally behind an access panel, the way you would be able to tell whether it is an oil-fired appliance or gas-fired appliance is by looking at the fuel line going to the appliance. With a gas-fired appliance, the fuel supply line must have what is called a drip leg. You can see what a drip leg looks like in the picture on the lower right. Now that we have looked at the different fuels and how to distinguish between oil-fired and gas-fired appliances, let's take a look at the different types of furnaces and their common basic parts. Furnaces heat a conditioned space by convection. Furnaces use ductwork to deliver the heat produced to the conditioned space and bring the cool air back to be heated. Furnaces have a supply duct and a return duct. The supply duct is the one that delivers the warm air to the conditioned space. The return duct is used to bring the cool air back from the conditioned space. All furnaces have a combustion chamber, heat producer, flame sensor, at least one heat exchanger, a blower, a filter, a means of protecting the heat exchanger from too high of a temperature, a way to ensure that cold air is not blown into the conditioned space, and a method to dispose of the combustion gases. On non-condensing warm air furnaces, the picture on the left, there is one heat exchanger. On a condensing furnace, the picture on the right, you will find two heat exchangers. On condensing furnaces, you will also find a means of disposing of the condensate that is formed. All furnaces today, whether they are non-condensing or condensing, also have a draft inducer fan. The draft inducer fan is to help pull the combustion gases through the heat exchangers. The non-condensing furnace is still able to be vented out a chimney and will have a metal flue pipe, but on a condensing furnace they must be vented with a plastic flue pipe. So if you look at the two pictures, you will see some things that can tell you which furnace is a non-condensing furnace and which is a condensing. One of the first clues would be what type of vent pipe is used. Another clue would be the condensate line on the condensing furnace. Furnaces come in four configurations. You have downflow, also called a counterflow, horizontal, upflow, and multi-position furnaces. When choosing which furnace to use, the position of the ductwork is one of the main determining factors. A downflow furnace has a supply ductwork at the bottom and the return air at the top. An example of where you might see a downflow furnace would be in a mobile home that has its ductwork in a crawl space below the home and the furnace installed somewhere in the living space. A horizontal furnace has the supply ductwork attached to one side and the return ductwork attached to the other side. An example of where you might see a horizontal furnace could be in an attic of a home. An upflow furnace has the supply ductwork attached to the top and the return air attached on the side at the bottom of the furnace. An example of where you might see an upflow furnace could be a home where the furnace is installed in the basement and the ductwork is above the furnace. A multi-position furnace is built so that with a few minor adjustments, it can be used in different positions depending on the ductwork. Now that you know how to distinguish between the different furnace designs, we will cover the basic parts of a furnace. We will start with combustion chambers. On a gas furnace, the combustion chamber is smaller than on an oil-fired furnace. An oil-fired appliance needs a larger chamber to properly burn the oil. I am not going to explain it further than that because it is beyond the scope of this class. The heat producer is the manifold on a gas appliance and the burner on an oil-fired appliance. The flame sensor is a safety switch. It is a device that tells the furnace if a flame is present. If the sensor does not sense a flame within a set time, it will stop the ignition and delivery of fuel to the appliance. It also will not allow the appliance to start the ignition sequence if it senses a flame when there is not supposed to be a flame. The heat exchanger is where the heat energy from the flame is transferred. As the flame burns, it radiates heat to the heat exchanger. As hot exhaust gases go through the heat exchanger by natural and forced convection, heat is transferred by conduction to the heat exchanger. The heat exchanger is constructed so the combustion gases and the house air supply are separate. All furnaces have a filter. There are different types of filters that can be used. The main purpose of the filter is to protect the fan and heat exchanger from damage. All furnaces have a blower fan that distributes the warm air and to bring the cool air from the conditioned space back to the furnace. All furnaces have a means to protect the heat exchanger from experiencing temperatures that could cause it to be damaged. It is called a limit switch, and it is a safety switch. It is a device that monitors the temperature of the air in the heat exchanger. If the temperature rises too high, it causes the burner to shut off until the temperature drops. There is also a means of ensuring that the blower does not start until the temperature of the supply air in the heat exchanger is warm enough to ensure that cold air is not blown into the conditioned space. The combustion gases must be removed from the furnace and disposed of to the outdoors. A vent system is responsible for this. When installing the furnace, the installation instructions will tell you the proper way to vent the appliance being installed. There are three types of boilers that are used to produce and deliver heat to a conditioned space. There are forced hot water boilers, steam boilers, and boilers that can be configured as either a steam or forced hot water boiler. Boilers can be constructed of cast iron or steel. All of the boilers have similar features. Just as a furnace, they have a combustion chamber, heat producer, flame monitor, a heat exchanger, a method to protect the equipment from too high of a temperature, and a method of disposing of the combustion gases. Boilers also have a means of protecting the boiler from excessive pressures and from the water level in the boiler becoming too low. A forced hot water boiler is designed to heat the water, and the heat energy from the water is transferred to the conditioned space. Since there is no change of state and only a change in temperature, the type of heat energy used is sensible heat. So for every pound of water in the system dropping 1 degree Fahrenheit, it will deliver 1 BTU. A steam boiler is designed to heat the water to the boiling point and change the water to steam. The main way the heat is transferred to the conditioned space is by latent heat. As the steam cools and condenses back to water, it releases 970 BTUs for every pound of steam. Boilers can either be a wet-based boiler or a dry-based boiler. What that means is that the combustion chamber is surrounded by water or the water is above the combustion chamber. If you look at the pictures, the one on the top left is a wet-based boiler heat exchanger. Notice how the heat exchanger is designed so water is all around the area that the flame is fired. If you look at the picture on the upper right, you will notice that the heat exchanger is positioned above the combustion chamber. The easiest way to tell whether the boiler is a wet or dry-based boiler is to look at where the piping is positioned. If you look at the picture in the upper right, you will notice that none of the piping for the boiler goes lower than 2/3 below the top of the boiler. That means the boiler is a dry-based boiler. If you look at the two pictures on the bottom, you will notice that some of the piping, the return line, is right at the bottom of the boiler. That means it is a wet-based boiler. On a wet-based boiler, which is the most common you will see, the flame from the burner radiates heat to the exchanger. The combustion gases rise through the heat exchanger by convection and transfer heat to the exchanger by conduction. How to tell whether a boiler is a steam boiler or a forced hot water boiler is actually very easy. If you look at the two upper pictures, you should be able to see some very noticeable differences. One of the first things you should notice is that a forced hot water system, the picture on the left, will always have an expansion tank. It is needed because the entire system is filled with water. What that means is not only does the boiler contain water, but all the piping is full of water also. The expansion tank gives the water a place to go when the water is being heated and it expands in volume. Forced hot water boilers also have circulators. Circulators create a difference in pressure to help move the water around the system. Another difference you will notice is that a steam system has a water level sight glass or gauge glass. A steam boiler must have room for the water in the boiler to change to steam, so the proper water level must be maintained. If the water level is too high, there will not be enough room to properly produce steam. If the water level is too low, the system is at risk of not operating properly. This is due to the fact that as the water turns to steam, it takes a little while for the steam to condense and return back to the boiler. It could drop the water level in the steam boiler below the minimum water level, and the burner will shut down. A forced hot water boiler does not have a gauge glass. The system is completely full of water. Also on a steam system, you will find a pressure limit control, a pressure troll, and a pigtail. A forced hot water system does not have that control. The common parts you will find on both a steam and forced hot water boiler are a boiler drain, pressure relief valve, low water cutoff, a temperature gauge, a pressure gauge, and high limit control. All of the parts except the boiler drain, temperature, and pressure gauges are safety devices. The safety devices are used to ensure the boiler only operates in a safe manner. The boiler drain, which is the upper left picture, is there so you can easily drain the boiler should the need arise. The pressure relief valve, the picture in the upper center, ensures that a boiler will not build up too much pressure and in worst case blow up. It is designed to open and relieve pressure if the pressure in the system reaches its setting. The temperature and pressure gauge is designed to show the temperature and pressure of the forced hot water system. The picture on the upper right is of a tridicator gauge. The red colored arrow indicates the normal range that the boiler should operate at. The picture on the lower left is of a pressure gauge. On a steam boiler, there is only a pressure gauge. The low water cutoff, the picture in the lower center, is installed on all boilers to shut off the burner should there be a loss of water in the system. On a forced hot water system, we have a high limit control called an aquistat. The picture on the far lower right is that of an aquistat. It ensures that the water temperature in the boiler does not exceed a certain temperature. When the water reaches the set temperature, the burner is shut off until the water drops in temperature. The pressure troll is the limit control on a steam system. It ensures that the steam boiler does not build up too much pressure. When the pressure reaches the setting on the pressure troll, the burner is shut off until the pressure drops. On the other slide, there is a picture of the pressure troll. All boiler and furnaces come with ratings. The ratings are on a plate that is attached to the boiler and the furnace. If you look at the boiler ratings plate and the furnace ratings plate, you will notice the different measurements used. There are things measured in MBH, BTU per hour, and inches of water column. MBH is just 1,000 BTUs per hour. A BTU per hour is the amount of BTUs that can be produced in an hour. If you look at the picture on the upper left, which is a boiler ratings plate, you see that the water MBH, which is 6 lines down, is 664. which means that the boiler configured as a forced hot water system, it would produce 664,000 BTUs per hour. If you look at the picture on the upper left, which is a furnace ratings plate, the gas input of the furnace on the top line is 75,000 BTUs per hour. To convert to MBH, you would divide by 1,000 and that would equal 75 MBH. When making low pressure readings that are a fraction of a pound, inches of water column is used. The unit of measurement refers to how many inches of water will create the pressure. Instead of using PSI as the unit of measurement, we use inches of water column to measure gas pressure because the pressure measurements are so small. 1 inch of water column is equal to 0.036 psi, or another way to look at it, is that 1 psi is equal to 27.7 inches of water column, which we round to 28 inches of water column. So if you took the maximum gas supply pressure on the second line, which is 7 inches of water column, and if you multiplied it by 0.036, you would see that it is only a quarter of a psi. If you were to use the 28 inches of water column as 1 psi, then 14 inches of water column would be half a psi, and 7 inches of water column would be equal to a quarter psi. A U-tube manometer is the simplest form of a manometer. A manometer is what is used to read inches of water column. Looking at the pictures of the manometer, you will notice the one on the left is filled evenly with water. The manometer on the right shows what happens when you are reading pressure. The manometer in the picture has a reading of 4 inches of water column. You add the numbers above and below the zero to get your reading.